going to have a look at question 9. So it says the first three terms of an arithmetic sequence given by 2x plus 5, 5x plus 1 and 6x plus 7. Show that x is equal to 5 is the only value which gives an arithmetic sequence. So first let's think arithmetic sequence means you are adding the same value or taking away the same value each time to get the terms in your sequence. So the idea is that the difference between these values, so this difference here and this difference here, they should be exactly the same, those differences. So we can basically just set that up as an equation. So I'm just going to zoom in on that a little bit. So let's have a go at that. So I'm basically just going to say, well, the gap between 5x plus 1 and 2x plus 5 is going to be equal to, I'm just going to write it down here because I've run out of space otherwise, the gap between 6x plus 7 take away 5x plus 1. That's all we're saying. Saying the gap between the terms is the same. It's just the algebraic terms. So that is going to give us, when we do that, so that'll give us 3x, 5x minus 2x is 3x, plus 1, take away 5 there, that'll give us a 3x minus 4. And that is equal to 6x minus 5x will give us a single x, and then 7 minus 1 will give us a plus 6. So we end up with that. And then let's just bring all the x's to one side and all the numbers. So that'll give us a 2x is equal to 10, meaning that x is 5. So therefore, it's the only solution, isn't it? So we can say, therefore, x is equal to 5 is the only solution. X is equal to 5 is the only solution. So that's the first part of the question, which I think is quite straightforward, really, isn't it? So let's then move on to part 2. So it says, write down the value of the first term in the sequence, and then part B is write down the common difference. So that should be quite straightforward. So the common difference is the difference between the terms. And then the first term is the first term in our sequence. So the first term, we normally label that as A. So A is 2x plus 5, isn't it? So let's just do that. So it's 2x plus 5. So it's 2 lots of 5, add 5. So that means 15. So A is 15 there. And then for the next bit to find the common difference, well, we just need to find the difference between two terms. So now the first term is 15. The second term is 5x plus 1. So let's find what that is. So let's do 5 lots of 5 plus 1. So that's 26. So therefore 26 minus 15 is 11. So the common difference is 11. And then if you want to make sure you're right, you can check that by finding the third term and checking if the common difference is again 11. Sorry, I realised the circle I put around that obscures the number. So why not? Let's do that. Why not? It's not going to take us very long, is it? So 6x plus 7. So let's put that in there. So it's 6 lots of 5 plus 7. So that would be 37. So again, 37 minus the term before it, which was 26. And that also gets us 11. So you can check that. And hopefully that'll give you some confidence that the rest of your answer is correct. So we've got an A of 15 and a D of 11. So then this is probably the actual crux of the question, the actual bit where we need to apply some A-level maths knowledge. So it says the sum of the first n terms of the arithmetic sequence is given by so we have S of n, so the sum of n terms is less than 1,000, and the sum of the n plus 1 terms is greater than 100,000, so we need to find the value of n. So it is still using this same sequence, it's still part of that same question. So let's think about, what do we know? Well, we know from the formula booklet what the sum of n terms is. So let's actually write that out. So the sum of n terms is equal to a half n, and then that will be 2a plus n minus 1d, like so. So we're using that. And then we already know from what we worked out before that A is 15, isn't it? A was 15 and D is 11. So let's put both of those in there. Right, let me get my pen up again. So we're going to end up with, so let's start with just a sum of n terms. So let's do Sn first. So we're going to do a half n, and then 2a, that'll be 30. And then plus 11 lots of n minus 1. And that is less than 100,000. And then I'm just I'll do the other one in a moment. So let's just expand all that out. So a half n, that would be 15n, we'll multiply that by 30. Then we're going to end up with 11n squared over 2. And then that'll be minus 11n over 2, sorry. And that'll be less than 100,000. And then all I'm going to do there to make my life easier is I'm going to get rid of the over 2 bit by just multiplying everything through by 2. So I'm going to end up with 30n plus 11n squared minus 11n is less than 100,000. Then hopefully we can see a quadratic there, can't we? So I think I'm going to rearrange that and solve that as a quadratic. So let's just rewrite it in the form ax squared plus bx plus c is less than 0. So that will become 11n squared. That'll be plus 19n and minus 200,000. Oh, I forgot to double that, didn't I? Sorry, that's a 200,000. When I double 100,000, it would become 200,000. So 200,000, and that is less than 0. And then I would just bung that in the quadratic formula, or you can use your calculator to solve that, whatever you want. So I get values of 100 minus 135.71, and I get 133.98. And then let's remember, if it's less than 0, let's think about our quadratic. So I'm just going to draw, because I would have to pitch this to figure out where my range is. So if I want to be less than 0, I'm under the graph, so it's between those two values. But let's think about it. For a series, it's not going to be negative. It's not going to be that negative value there. So we'll get rid of that, because we can't have negative terms. It doesn't make any sense. So I'm going to take, so this is my highest value here. If you think about it, that would be basically this value on my graph here. So we want values lower than that. So I know, therefore, that n has to be less than 133.98. So I know that bit, but then I've got another equation, so let's think about that, because that tells me it's less than that, but I don't know what's happening in the other end of that. So that's where we're going to have to use the second equation that we were given, which was the n plus 1 there. So we know that so the sum of the n plus 1 terms is greater than 1,000. So let's do it for the n plus 1 now. So we're doing, so s of n plus 1 now. So that will be a half n plus 1, and then that will be 30 plus 11, and then it's n plus 1 minus 1. So they're going to effectively cancel out, aren't they? And that is greater than 100,000. So then let's tidy all of that up. So I believe that's going to get me there. So I'd end up with a 15n when I do a half n times by 30, and then plus a 15 when I times a half by 30. And then I'm going to end up with 11, and then I'm just going to cancel those out because they cancel out. So it's just 11n here. So that's going to be, when I times it by a half n, that will be 11n squared over 2. When I times that by a half, that'll just give me 11n over 2. And then that is greater than 100,000. I'm going to do the same thing I did before and just double everything, because I'd prefer to do that and make everything a nice number. And then just rearranging all that, I get 11n squared. And then that'll be plus a 41n. Then I get minus 199,970 when I do that. And that is greater than 0. And then again, however you want to solve that, either bung it into your quadratic formula or use the solver tool in your calculator. So I get values of 136.71 and I get a value of 132.98. That should be a 9. And again, thinking about what the graph looks like. So now I want to be above 0. So it's these values here. So n can either be less than 131% 1, but again, we know we can't really have negative terms in a sequence. So that doesn't make any sense. So it's going to be this value, and that should be a 2. It still looks like a 7, but it's a 2. We can see that n would have to be greater than that. So we end up with these two things. I have n is greater than 132.98 and n is less than 133.98. N should be an integer value because we're talking about term numbers. So I feel that means that because of that, n must be 133 because that satisfies it's bigger than 132.98 and it's less than 133.98. So n must be 133.